We're given the following information about a portfolio that has two equally weighted stocks, P and Q. So this means in the portfolio, you have 50% of stock P and 50% of stock Q. And we're given the economy over the next year could be good or bad with equal probability. And the returns of the stock can vary as shown in the table below. Okay, so we're given the return of P and Q when economy is good and return of P and Q when economy is bad. And these happen by equal probability, so this should be 50% for both. And we want to calculate the volatility of the portfolio return. And to calculate the volatility, I'll just indicate as sigma P, sigma portfolio. And to calculate the volatility, we need to calculate the variance of the portfolio because the volatility equals the square root of variance of the portfolio return. Okay, to calculate the variance of portfolio, the formula is the weight of, okay, I can't just put P because I'm going to use the same variable later, so I'll just put it as this. Yeah, to calculate the variance of the portfolio return, it'll be weight of P in the portfolio, the square times expected variance of P plus weight of Q in the portfolio squared times variance of Q plus 2 times weight of P times weight of Q plus times covariance of R and Q. Okay, so we're given, okay, looking at this formula right here, we are given the weight, okay, so we're given the weight of P and Q by the first sentence. They have the they're equally weighted, so the weight should be 50% for both. So we can say 0.5 for both. And we don't know the variance of P and Q, and then we don't know the covariance as well. So these are the three values that we need to calculate. 1, 2, and 3. Okay, let's tackle the first one first. For the first thing first. Yeah, that was good. Okay, to calculate the variance of P, the formula would be expected return of P squared, okay, minus expected return of the P squared. Yeah. Yeah, to calculate so we have to calculate the expected return of the P first, and it'll be the the return of P would be 10% by 50% chance, and negative 2.2% by 50% chance. So it'll be so putting that in a formula, it'll be 0.5 times 0.1 plus 0.5% of probability times the expected return in that scenario. So yeah, in other words, the expected return of P equals the probability of the economy being good and the expected return in that situation when the economy is good, and the probability of economy being bad times the expected return in that situation, which is negative 0.02. So, calculating this, I get um, 0.05 plus minus 0.01. We get 0.04. And expected return of p squared equals, we just have the same probability and we square the returns. So we put it like this. So 0.05, so 0.5 times 0.01, 0.1 squared plus 0.5. So the probability times the square value of return. And when we calculate this, we get 0.0052. So now we can calculate the variance of p because we have all the values to calculate the variance of p. And by plugging in the values we got, it would be 0.0052 minus 0.04 squared. And this would be 0.0036. Okay, now, let's go for the second things to calculate. So variance of P calculating Q would be the same procedure as Q. It would be expected return of Q squared minus expected return of Q parentheses and square. Okay, to calculate the expected return of Q, it would be probability of the economy being good, which is 50%, 0.5 times the expected return of Q when economy is good, which is 18%, plus 0.5, the probability being economy being bad, and the expected return of Q when economy is bad, which is negative 0.05. And when we calculate this, we get um, we get 0.065, and now we can calculate r squared of Q, and it is just same probabilities, but we just square the returns like this. So you get 0.18 squared times 0.5 equals 0.0162 plus 0.05 squared times 0.5 equals 0.00125. And then we get 0.01745. Now we can calculate the variance. So plugging in those values, you get 0.013225. Okay, now last things to calculate the covariance. So to calculate the covariance of R and Q, um, the formula is expected return of R. Oh no, never mind. This is P and Q, right? Yeah. Covariance of P and Q would be expected return of P and PQ minus expected return of P times of, I'll write it like this. minus expected return of P times expected return of Q. Yep. Yeah. And we have these second term from the previous calculations. And the only thing we need to calculate is expected return of P times expected return of Q. And this is pretty simple as well. It is the first first things we have is the probability when economy is good, and we just multiply the returns of stock P and Q when the economy is good, which are 10% times 18% plus probability of the economy being bad, which is 50%, and we multiply the returns when the economy is bad, which are negative 0.2, negative 0.2 times negative 0.5, respectively. Now we get wait, for the first term we get 0.009 plus, and the second term would be 0.0005, and we get 0.0095. Okay, now we can calculate the covariance because it would be 0.0095 minus 0.04 times 0.065, which equals 0.0069. Okay, so by substituting, now we can plug in all the values we have calculated. So it would be 0. Yeah, for variance P, we calculate that it was 0.0036, and for variance Q, we have calculated that it was 0.013225, and for covariance, we have calculated that it is 0.0069. Okay, we just need to substitute all these values, and now we get. Let's see what we get, and be careful not to make calculation errors. Okay, once you do this, you get. Okay. 25. Oh, wait. I almost made the calculation error. You have to multiply 2 in front of that. Yeah. And okay. When I calculate this, I get 0.007656. And when I square root that, I get exactly 0.0875, which is 8.75%. So the answer would be D. To solve this question, to summarize, you have to know the formula that the variance of the portfolio equals the weight portfolio would be weight of stock A, 1, times the variance of stock 1 plus weight of stock 2 times variance of stock 2 plus 2 times weight of stock 1 times weight of stock 2 um, times covariance of stock 1 and 2. Oh, and yeah, you need squares for both of them. And yeah, and to add a bit, covariance of R1 and R2 would be expected return of R1 times R2 minus expected return of R1 times expected return of stock 2.